Let's look at some equivalent expressions with exponents, okay? Hopefully by now we understand that what an exponent means. It just means we're using this base number this many times in multiplication, right? So we have 4 2's that we're going to multiply. All right, so in this case we're going to have, and let me go back. So there are 4 expressions here. Let me underline them. Here's our first one. Here's our second expression. Kind of cut through that 50. Sorry about that. Here's our next expression. Oh, and we've lost one in here. Oh, no, we didn't. I'm just a little over extended right there. Okay, so there's our next expression right there. And our final expression is down here, starting with the fraction 2/3. Okay, so let's go ahead and solve each one of these to prove that they are equivalent expressions. Because I know you're thinking, Ms. Brock, there's no way those are the same. And you're going to have to create your own equivalent expressions, so I want you to see that these are in fact equivalent. Okay, so we have 2 multiplied by 2, multiplied by 2, multiplied by 2. 2 times 2 is 4, times 2 times 2. 4 times 2 is 8 times 2. 8 times 2 is 16. So we're looking for all these equations to be equivalent to 16. Next one, let's go ahead and rewrite this. We have 12 minus the sum of 2 to the first power, 2 squared, plus 550ths. Okay? So let's simplify this that's in the parentheses because we're working here with order of operations. So the first thing we need to do is take care of this in the parentheses. 2 to the first power is just 2. 2 to the second power is 2 times 2, right? So that's 4. So we're going to erase that. We don't need that. It's just a reminder. Okay, so that's 4. So we have 12 minus the sum of 2 plus 4 plus 550ths. Okay, next step, simplifying even further. 12 minus 6 plus 550ths. Simplifying even further, as far, we're working from left to right now because we took care of the parentheses. We've got 12 minus 6, which is 6, plus 550ths. Simplifying 550ths, we're going to have 6 plus 10. And that's because we can divide both the top and bottom by 50. Okay, oops, 50. This becomes 10, and this is 1. So thus 10, and we have 16. So proof. This also is 16, so equivalent. Okay, let's look at this one underlined in blue. We have 2 cubed plus 2 cubed. Well, 2 cubed is just 2 multiplied by 2 multiplied by 2. This is 4 times 2. This would be 8. And since we have 2 of those, it would be 8 plus 8, which is 16. So thus proving, again, equivalent expression. Okay, last one. Let's go ahead and solve this one. We have 2/3 multiplied by 48 to the first power minus the sum of 1 plus, whoops, what am I doing there? Sorry about that. Okay, 1 plus 3 squared. So let's take care of our parentheses first. So let's rewrite this. And just a reminder, that is multiplication right there. Just so much faster to write a little dot than having to write that, what looks like an X. Okay, the sum of this would be 4, and that would be squared. And so that would be 16. All right, so 2/3 of 48. So we're going to do 2/3, and we're going to do is multiplying 48. So 48 to the first power is just 48. Like right here, we had 2 to the first, and it was just 2, right? Because we're only multiplying 48 one time, and so we're not multiplying it by anything, right? It's just itself. All right, so we have 48 over 1. 2 times 48 is, what is that, 96? 96 over 3. Now let's simplify that, so then we have, so that we did this here to get to this point here. Minus 16. Let's simplify 96 over 3. How many times can 3 go into 96? Well, it can go into 3, or to 9 3 times, and it can go into 6 2 times. So then we have 32 minus 16, and 32 minus 16 is in fact 16. So as you can see, by our evaluating each one of these expressions, we did prove that these were equivalent expressions.